Welcome to Siding Institute. We are going to do question. This is MSM 11 tutorial sheet 1. The question reads, let x is equal to the brackets. As you can see, we have the open and the closed bracket. I'm going to explain this. B, the universal sets, and A is equal to -1,4, B is equal to 0,9, and C is equal to -3,6, B the subsets of x. That means to say A, B, and C are subsets of x, meaning C is x is the universal set. Find each of the following and display them on the real line. Alright, very important question which you are going to find out in your exams and in your tests. So we are going to do this question step by step, guys. We are going to do question A, 2, and 3, then 4 and 5 in the next video, because I want to do this step by step. That's why I can't answer this at the same time. Okay, so let's get started, guys. Alright, so let me explain these two brackets. We have this. Is my pen activated? Okay, let me use blue. Okay, so we have this bracket. We also have this. Alright, so when you see this is what we call an open bracket. Okay, this is an open bracket, and this is a closed one. Okay, it is called a closed bracket. So when do we use these two? Very important. We use an open when that number is not included. Okay, not included. Then here we use this number when it is included. Okay, so let's say, for example, we say x is a member of natural numbers. Okay, is a member of natural numbers where 1 is less than x, less or equal to 3. Alright, so what are natural numbers? I'm trying to give you this so that you know in advance. I don't want to go direct and answer and then you get confused at the end. This means that this set can be written as, by listing, we know natural numbers are counting numbers. Since 1 is less, it means that 1 is not part of the solution set. So we are going to have numbers which are less than 1, but less or equal to what? 3. So we are going to have 2 and 3. Okay, so these are numbers by listing. Now, in interval notation, we are going to write this. We are going to write 1, what? 3. This means to say that 1 is not part of the solution set. As you can see, the solution set is this. It is not part, but 3 is part of what? Of the solution set. So when you see this and you see this, it is one and the same when they are talking about what? Natural numbers. So let's go ahead now and start answering. Okay, another thing. Once we start displaying sets on the real line, this bracket can be represented by an open and a circle which is not shaded, and this one can be represented by a circle which is shaded. When you say a circle is shaded, it means that that number is included. And in this question, I'm going to be using these two instead of this. Okay, but if you want, you can use this, but I'm going for this because I'm used to use these two. Alright, this is the interesting part of this question. It is likely to be asked in your exam. So first you have been asked to find the set, the hair complement, then we display this on the real line. But I always encourage to start displaying on the real line, then you find the set. It is very simple. So what's our first thing we are going to do? We are going to draw the line. The line of our what? Of our x. So this is our x, okay? This is our set x. This is our set x. We have it is running from -10 up to 10. You need to include this. Okay. So I said I'm going to use this bracket. Okay? You know this bracket. Or let me not confuse you. Let me just use the bracket which have been used instead of circles. Okay. So I'm going to use this circle to show that it's not included, and here to show that it is what? It is included. what else have we been given? We have been given now set what? Set A, because now since we have the universal set, we have been given now set A. So since we have been asked to find A complement, so we are going to remove A from the universal set. What is going to remain, guys? It is the A complement. A very simple explanation which you need to know. Okay. Thus, we have been given out to find A complement. So we're going to write A. So A is running from -1. We can estimate that -1 is here. And our 4 is here. You don't need to give the actual here. We are estimating. So this is starting, our point is starting from here to this point. Okay. So this is our what? Our set A. Okay, this is our set A, and we know that set A is included, 4 is included, and even our -1 is included. Now, how can you find the A complement? Meaning, when we remove A, what is going to remain from this line is the A complement. Complement, guys, they are just telling us to remove A from the universal set. Okay, so we are going to remain with this part. We have remained with this part. We've also remained with this part, you can see. Okay. So now the question becomes here. Because here we already know that 10 is included. Okay. We also have know that -10 is not included. This is our A complement. This is also our A complement. Student gets confused on this part, and I don't know why, because these things are very, very simple. So guys, we are removing the segment of A from the universal set, so that we may find the A complement. Now, we are going to ask this question. Since 4 is part of A, is it going to be in the complement? No, because it has already been removed. So we are going to have an open circle here. Okay? -1 is part of the... This, guys, let me give you this question. In fact, I'm going to answer only 2 questions since I think I'm going to take time. I want you to understand. I don't want to rush. Okay. This means to say, let the universal set been given to be 3 and 4. To be our universal set. And our set here has been given to be 1 and 2. How do we find the A complement? We are going to remove set A from the universal set. We are going to remain the A complement. We are going to remain with 3 and 4. Okay? That means, since 2 is part of set A, it is not going to be part of A complement. Okay? That means 4 is part of set A. That's why we have our crossed bracket here. It is not going to be part of the A complement. Even here, 1 is part. We can see from this. So it is not going to be part of the A complement. This is how you represent the set on your number line. You can even shade in different colors so that at least my work may be very clear. Don't attempt that in your exam to use different colors here. So I'm going to shade A complement is from this point. Okay, you can shade. Okay, you shade. This is how you represent this on the real line. Alright, so now, by so doing, then we've represented what? A complement on the real line. So what is remained is to answer now, because our first was to find it. So what we are going to say is that A complement is equal to, now we're going to start from this point, because A complement is running from this point up to this point, and from this point up to this point. So I'm going to have -10 not included. We're following the brackets. Also -1 is not included. To add 2 sets, we unite, we say the union. This is what you do when you're adding. Then 4 is not included in the A complement, but 10 is included. This is how simple, guys, you can find this kind of equation. Very, very simple. So understand the steps which I was just giving, guys. Nothing like stressing yourself answering this kind of a question. So let's go and do question B. I'll be fast with question B now, because you know how basic concepts you need to know. We are now on A intersection B. Our first thing, we draw our hex, which is running from negative 10 up to 10, will be first, included, not included. Our first thing now is to write A, because we have here. We know that our here is from negative 1. Okay, so we're going to say negative 1. Let's say negative 1 is here. Okay, and our negative 4 is here. So all these are included. Our B is starting from 0, so we can indicate 0 here. 0 can be here. We say we can estimate 0 can be here. Then our 9, it is almost to 10 here. It's going to be here. Okay, so after this, now we can just represent the sets on the real line. Set A is from this point all the way up to 4. And both we know that we have the brackets like this to show that it is included. Okay, what about B? B is running from 0. Okay, from 0 all the way up to 9. 0 is here all the way up to 9. Okay, and not included. We are using these brackets. We are following the brackets which our B has. This is our B. Okay. So now the question is the intersection part. Where is the intersection part? It is where the two lines are meeting. A intersection B. They are talking about the members which are finding in both sets. So under the real line are the region where the two lines are meeting. So you can see that the two lines are meeting from this point all the way up to this point. This is where are the two lines meeting. Okay, all the way up to this point. Now let's now talk about the numbers. Are we going to write here these brackets or this? This is our next question. So we know that 0 is part of A, but is not part of B. Okay, because of this bracket, 0 is not part of B, so it is not going to be in both sets because it's not part of B. So I'm going to write this. What about this part? 4 is part of A, that's why it is included here. And at the same time, it is part of B because it is in between B. You can see it is in between B. B is running from 0 up to 9, and 4 is in between here. So we are going to say 4 is included even in A intersection B. So we are going even to say that this is A intersection B. So guys, like the way I'm presenting my work is how you need to present your work, step by step, so that even the marker we will know that this guy knew what he or she was doing. So you know that if he first found the A, then B, then he talked about where the two lines are meeting. So you can even shade to say that our A intersection B is here. This is where the two lines are meeting. Even by not shading this, it's fine, as long as you have now indicated to say that our A intersection B is this line. Okay, so now to write the answer, we are going to write. We are following the line. The line is moving from 0 up to 4. You can say that this is up to 4. Okay, where 0 is not included, we are following this now bracket, and 4 is included. I don't think this kind of explanation can skip someone's ears, because I've tried by all means to reduce my speed. As you can see, this is not the speed at which I move when I'm teaching, but by all means, so that I may try to make sure you understand. So we are going to do question 2, 3, and 4 in the next video. So guys, this is the end of our today's tutorial. If you find the video help, consider subscribing to the channel. You like the video, also hit the notification button so that you may not miss out on uploaded videos. So the password is simple, is this one. This has now become a password to all NSC students. If you want to do better, just register to Sidon Institute. Inbox me at this number. We talk. Registration is only 60 kwacha per course. If it's biology, chemistry, maths, physics, you are all covered. Only 60 kwacha per month. You get access to all our services. So thank you for watching. See you in the next video. Alright, so I feel like continuing answering. Let me just answer this question like the way it is. So let me go ahead and answer question 3 because I promised even to answer question 3. Let me answer question 3 then 4 and 5 I'll answer in the next question, in the next video. Alright. So this question is very similar to the first. So we start with the universal sets. Okay, this is our X. Alright, so what have we been given? We have been given also A and B, so we are starting at -1. You can say -1, we have 0, we also have 9 here. -4, okay, or 4, because we have 4 in here. So we start with set A. Set A is starting from here, who are included from -1 up to 4. We are now familiar with this. And our set B, let me just use blue so that I may be fast, is from 0, starting from the line of 0 here up to 9. Wow, not included. We must use these brackets because 9 and 0 are not included in set B. Okay, so this is our set B. So the first is to find the union. So the union is all the way from this point up to this point. Now they told us find A union B complement. That means we are going to remove A union B from the what? From the universal set. So we are going to remain with this part. Let me use the other color. Universal set which has remained, we have remained with this part. We've also remained with this part. Guys, these things are very simple. So what has remained is what we are calling A union B complement now. Because we have removed A union B complement. Our last work now is to decide, to make a decision of the bracket we are going to use. We can see that -1, this bracket is telling us that -1 is part of A union B. Okay, so since it is part of A union B, it's not going to be part of A union B complement because it is already in A union B and we have removed A union B. So we're going to have this bracket here, and here we already have, this has no effect, we just take it like the way it is. So even here to the last, we use the bracket according to this bracket which is A. So our decision is going to be 9. 9 is not part of A union B. Okay, so removing A union B will still remain with 9. Okay, so 9 is going to be A union B complement. Somebody is not understanding here. What I'm trying to say is this, guys. We know that 9, this bracket here is telling us 9 is not part of A union B. So even after removing A union B, this 9 will still remain because it is not part of A union B. That's why in A union B complement, this is going to be part. That's why we are using this bracket. Yes, guys, this is how simple you can just spray these sets on the real line. If you want to shade, you can even shade these parts. Okay, you can shade these parts. I never used to shade this. We've represented them. So this is how you display now. Our last part is just now to write the set itself. So we are running from -10, it is not included, to -1. The bracket is telling us it's also not included. Union, who are included here? 9, because we have 9 here, and 10. Very simple, guys. So this is how simple you can handle this kind of a question. If you find the video helpful, consider subscribing to the channel. Like I said, that I don't take long to make videos, but this have exceeded the 15 15 minutes because I wanted everyone to understand this. Alright, so this is the end of our today's tutorial, guys. If you find the video helpful, consider subscribing to the channel. You like the video, don't forget to register to Siding Institute. You will benefit a lot because these are the questions, the same question are the one you are going to find in your exams. Because this is tutorial sheet 1. Expect this tutorial sheet. Okay, let me show you now what I said I'll show you. Let me show you. I said I want to show you. This is tutorial sheet 1. And this tutorial sheet has got about 4 topics in it. So by answering this question, you'll be ready to do test 1 without any problem. Because this question 1 is on sets, we answered. So if you register, you'll be able to access the solution to all the questions. This is question 2 we are doing, guys. Okay, you can see this. So for those who have registered, all the solutions are going to be sent to them. You can see how you can display sets on the Venn diagram here. You see, these are the questions you're going to find in your exams, guys. Be serious when it comes to tutorial sheets. That's why Siding Institute is there by your side to help you do anything without stressing yourself. Question 7 about simplifying sets, very simple. Then question 7a, it is on De Morgan's laws of sets theory. I got this area. Then question 8, it is on how you can change decimal numbers into fraction. There is a simple method which we use than the one you learned at high school. Wow, question 9, very interesting, powerful questions in your exam, how to prove irrational numbers. Question B, an exam question you always found in your exam, on SADS. Also question B, it is on SADS. Question 10, functions, the longest topic in semester 1, functions. So all these are functions, guys. The domain and the range of a function, well covered. Then finding the domain, that is question 13. Then question 12 is on equal functions, how you can find the equal functions. Very simple, we have answered all these questions. Question 10 is on what topic is this? What's the subtopic is on composite functions. Yes, you find the composite function and at the end you find the domain and the range. Question 15, even, odd and neither even and odd functions, very important. You need to know what are even and odd functions, how to skate radical functions. Hey guys, you have no reason to fail if you just register. These questions will come in your exams and you will tell me how to skate 16, 17. In fact, you have when you start answering this question, you have started entering into serious mathematics, not those jokes we were doing. Though they are part of our exam, that they are jokes, you don't need to think, but here your brain should be thinking on skating modulus functions, question 17. Okay, so I want my guys to show you all the questions. Okay, question 19, 20 to 21, binary operation, very important. Already solved these questions. So guys, if you just want all the solution to this tutorial sheet, why can't you register to Siding Institute at 160 kwacha so that you may have access to all the tutorial sheets? I'll be taking you step by step until you pass your natural sciences without even stressing. So thank you for watching, guys. See you in the next video. If you want to register, I've already shared the line.